This class. Of course, we got a lot to do today, and of course, I we advise you stay focused in case you need clarification or you get stuck. Please let me know. Okay, so we studied conditional probability and Bayes rule. But before going into that, I will need to shed more light on a particular principle that we call the principle of inclusion and exclusion. I think I derived that for two events the other time, and that is where I'm going to start today. And all what I need you to do is to pay attention. Let me say this. What determines the probability formula we're going to use in a given situation depends on types of events. Okay? The type of events will actually determine what probability formula we're going to use. So I want to talk about two types of events, and you see how it is related to where we stopped the other time. Where we stopped the other time also very crucial to what we're going to be doing today. Now, one, we have what we call mutually exclusive event. When I talk about mutually exclusive event, I'm talking about having events A1, A2, okay, blah, 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 up to maybe AN, that, they are disjoint. If they are disjoint, okay, if they are disjoint, and I want to find the probability that at least one event will occur. I'm going to say that again. I want to find the probability, I want to figure out probability of at least one event occurring. Okay, this is going, it means I actually want to figure out the probability of A1 union A2 union blah blah until I get to AN. This is going to be the same as this, adding the probability all together. Okay, now in a short form, I'm actually going to write this as I start from 1 to N, AI, okay, and this is going to be summation. I start from 1 to N, the probability of AI. Now, what am I talking about? Please pay attention. If you don't understand, ask me a question. I'm talking about mutually exclusive event that cannot occur together. Okay, when A1 occur, it will prevent the others from occurring because they are disjoint. And what I want to figure out here is, what is the probability that at least one occur? The probability of at least one occur is going to talk about union of all the events, the probability of the union of all the events, and that is going, if I want to go by additivity in the common God of axioms, it's going to be addition of the individual probability, okay? And in the short form, so when you see this, then we are trying to figure out what is the probability that at least one event will occur in a situation where events are disjoint. But I'm going to give you another. Those of you over there, can you see this board? Okay. Now, I want to go to the next one. Non-mutually exclusive event. When I talk about non-mutually exclusive event, okay, if I have event, you know here, if you only have two events, if you have two events, here, let's say you have events A and B, then the probability of the union is just going to be this. Okay? This is when you have two events. I can use A and B. I can use A1, A2. That's no problem. Please pay attention. Okay? Now, this still fall under, mutually exclusive event. But if I want to talk about non-mutually, and I still want to find the probability of at least one event occurring, I still want to find the probability of at least one event occurring, okay? Then I still want to find the probability of the union. Let's say for instance, I got A1 and A2. Okay, A1 and A2 are non-mutually. Okay, when we say non-mutually means they can occur separately, they can also occur together. But in this situation, they can only occur separately, they cannot occur together here. Does that make sense? But now, in this situation now, it means I want to figure out the probability of A1 union A2, which is going to be probability of A1 plus probability of A2 minus the probability of A1 intercept A2. Now, this is the overlap. The overlap needs to be subtracted. You can see the difference between this guy and this guy. Okay, if you take a look at this guy, okay, this entity equal to 0. Okay, which means here, okay, here, the probability of A1 intercept A2 is 0. And why is it 0? It's 0 because this guy is empty. In the case of that guy, no connection. But here, the probability exists. That's how I'm going to subtract that. Now, this guy here, if I now want to have more than two events, okay, if I have more than two events, this is going to be A1. Give me 1 second. Okay, that is that. So this is going to be A1 union A2 union A3 equal the probability of A1, the probability of A2, the probability of A3, the probability of A1 intercept A2, the probability of A2 intercept A3, minus the probability of A1 intercept A3 plus the probability of A1 intercept A2 intercept A3. Now, in a situation where I got 3 events, okay, and these 3 events are non-mutually. Now, if they are non-mutually, and I want to find what is the probability that at least one event occurring, okay, this is what I'm going to get. This is for 3 events. This is for 2 events. Okay, now, in this situation now, you see that we are adding the individual probability, we are subtracting the overlap, okay? We are subtracting, the overlap, and we are adding the higher order overlap, okay? So this is the situation here. Now, I want to generalize this. What if in a situation where I have more than 3 events? How do we generalize that? And I still want to find the probability of at least one event occurring, okay? And I still want to find the probability of at least one event occurring. Please pay attention, okay? Pay attention. If you don't understand, ask me a question, okay? What we're doing now is very, very crucial. You can see that's why I'm using the board. Go ahead. Okay. Okay. Uh, you know, here, okay, let me do this. Let me go into real world example. Let's say, for instance, let me take the example from number one, marketing. I want to take example from marketing. Okay. Now, a particular company is trying, reach out to customers on different social platforms, Facebook, Instagram, okay, maybe TikTok. Okay, they reach out to them, probably they advertise their product. Now, customers overlaps on social media. Some customers, they are on Facebook, they are also on Instagram, they are also on TikTok. I want you to see this as A1, A2, and A3 that I'm talking about. Now, this particular company want to find what is the proportion of reaching out customers in at least one social media platform. You know, I'm talking about at least one event. Okay, in at least one. Now, I have to use this. Why? This guy is called principle of inclusion, exclusion. Okay, I'm going to tell you why it is called inclusion, exclusion. Inclusion will be, I will consider those that are on Facebook, that are on Instagram separately, that are on TikTok. Then, I will, in order not to have a double counting, I'm actually going to, removing this and this is to adjust for overlaps. You know, situation where A1, A2 me, those that are on Facebook and Instagram, we don't want them to be double counted. Otherwise, it will affect the results. So here, how can we do it in such a way that we're actually going to adjust for the overlaps? In adjusting for the overlaps, the first interaction, the first order interaction is when they occur in pairs have to be removed. Why are we subtracting this? Because they've been added so many times. Okay? Why are we adding the higher one? Because they've been subtracted many times. So doing this and this, we are adjusting. Does that make sense? And that is the essence. Now, I can use another typical example in epidemiology. In epidemiology, now I need you to pay attention. In a community, maybe 30%, okay, has fever, maybe 35% with cough, right? And maybe 20 with sore throat. Okay? Now, symptoms overlap. We have some people that have both this and this at the same time. But in this community, they want to figure out what is the probability that individual will have at least one symptom. Now, to be able to do that, we need to make use of inclusion, exclusion, so that we don't want situation whereby people with multiple symptoms will be overcounted. Does that make sense? Now, that is the application. Okay, the application cuts across the field. Now, if I want to generalize this guy, if I want to generalize, what I'm actually going to do, okay, the generalization will be the probability of the union, I start from 1 to n, of AI. If you take a look at this, what am I saying? What am I saying here? I'm generalizing. Instead of me to stop at A3, I want to stop at AN because there could be so many events, okay? It's going to be equal to the first thing that you're going to see. If you look at the para, right? the first thing is going to be the addition of the probability, right? So there is going to be summation. I start from 1 to n, the probability of AI, right? What is the second? The second is subtraction, right? Then I'm going to do minus summation. Okay, I less than j. Okay, the probability of AI intercept AJ. Okay, you know, I say I less than j, of course. 1 is less than 2. 2 is less than 3. 1 is less than 3. Does that make sense? I'm writing the general formula now. Now, plus, don't forget, in the plus, you know, when you have a 2 event, the next is going to be 3 event, depending. So here I'm going to say summation I less than j less than k, the probability of AI intercept AJ intercept AK. Okay. Now when I have that, then I'm going to have minus dot, 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 plus. Then there's going to be an alternating series. So negative 1 raised to power, let me do this. Let me get this one up. Okay, so negative 1 raised to power that. Then I'm going to have this guy. I start from 1 to n, the AI. Now, what you see here is the generalization of the inclusion and exclusion principle. In case you have, depending on the number of events that we have. Okay, so what I'm trying to say, I want to figure out the probability of at least one event occurring. Okay, and then I need to consider the sum of individual probability. Then I need to subtract the overlap because this overlap was added many times. Okay, then I need to add the higher order overlaps, okay, because this was subtracted so many times. Then this is alternating the series. Okay, I'm going to be alternating the series until all the overlaps are accounted. We have to account. You know, we are accounting, okay, for overlaps. Okay, so if you want to, actually, if you're interested in using, you want to figure out the probability of at least one event, or you want to figure out the probability, for instance, in system engineering, in computer networking, where failure could occur. You know, failure could come from server A or server B or from the cable, okay? Because failure can take place simultaneously. If I want to figure out the probability of the total failure, depending on whether you have component, of course, you know, components make up a series, right? I mean, make up a system, right? Depending on the arrangement of the component, whether components are arranged in series or they are arranged in parallel, you may want to figure out the probability of a failure, of a total failure. Then you're going to make use of inclusion and exclusion principle. Okay, that is just from there. Now I'm going to go back. That settled, you know, where we left the other time. Okay, I believe you understand that now. Then I want to go back, you know, projecting. Okay, I want to go back to projecting. Like I said, I understand my mathematics, why, you know, when I try to relate to real life. You need to relate to real life, okay? Otherwise, it's not going to make sense. Now, you all know reason why we apply inclusion and exclusion principle. That can only, you know, be applied if you're actually talking about, you want to figure out the probability of at least one event occurring. Now, away from that, I want to walk you through